Oh, my birthday's on a Thursday. That's lame. I suck.
All right, you said number 2, Linksy?
That's a GHQ gauge.
I'm sorry, mine, I guess.
Gauge.
Good job.
Cool job. Taking your
We'll do number 1 after this, right?
No.
Yeah.
Yeah.
What?
I looked at it.
What
I
section
actually
are we
got-
on?
Yeah, I also attempted, but then like, yeah.
What section are we on?
10-1.
I missed the lesson.
You missed what?
Is it hard?
No.
That's what
I
I
got it still my junior year.
Okay. So, Linksy, we're trying to make this fit into this. Okay, so we're going to change y prime to the derivative, which is if you go cross rule, first one, derivative of the second one, plus second one, times the derivative of the first, and the derivative of negative cosine is positive sine, right?
I have a question.
What's that?
How come we just don't throw it in for y?
We're going to do that also.
Right, right now.
Well, I was just going to figure out what the derivative was first, and then substitute in for y prime and y at the same time. Okay. All right, so then this equals cosine squared, unfortunately minus sine squared, plus sine, right? So now you got the derivative linking. Okay. So now I can rewrite this equation here that we're trying to show that this is a solution to with cosine squared of x minus sine squared of x plus sine of x plus tangent of x times y, which is sine of x, cosine of x, minus cosine of x. So when we simplify that, we want to equal cosine squared of x.
That's a large amount of stuff.
But I feel pretty good about it.
What did we add together?
What's that?
What did we add?
Why did we add what together?
Like we added the cosine squared of x minus sine squared of x, and then we added the.
Because that's what it says right here.
Oh.
Okay. So all I did is I took the derivative, replaced the y prime with what y prime equals, right? And then replace y with what y equals, right? And then now we're going to simplify. Okay? So, I have confidence that this is going to work out so nicely because tangent is what? Was 1 over cotangent, but it's sine over cosine, right?
Wait.
Tangent I can replace with sine over cosine, right? So if I distribute this, yeah, the cosines will cancel. And so that gives me sine squared, right?
Wait. Okay.
Okay? And then if I go sine over cosine times negative cosine, the cosine cancel again and give me negative sine.
Isn't it sine x minus sine x?
Isn't that sine x minus sine x?
No. Got it.
And then negative sine squared, positive sine squared cancel. Sine cancel. Cosine squared equals cosine squared. Everyone's a winner.
So what's the y?
Yeah, I'm not really sure. What's that?
Oh yeah.
Yeah, against Houston.
Hey, don't matter. A win's a win. That's a
Shut
big
up.
win. That's a big
It
win.
wasn't Freddie, was it? Saunders Felix, was it?
It's Saunders.
Oh, what?
Freddie, that's old school.
Garcia? You talking about Garcia?
Freddie, that's old school.
I know, I always get Felix and Freddie mixed up. Do you really want to do number 1?
Yeah.
Okay.
Yeah.
Tyson,
Number 2, it says at the very end on the interval, like,
It's just with the trig functions, if you don't restrict it to a certain domain, then it goes on, you know what I mean, it goes on forever, so.
I got it. I got
You
it.
got number one?
Yep.
Okay. Yeah, you guys didn't need help
Good
with
for
number one.
you.
Not good.
I'll get it.
So same thing as that other one. We're trying to show that this right here is a solution to this right here, right?
Oh, yeah.
So I need to take the derivative, because I need to substitute the derivative into that.
Oh.
So the derivative of x is 1. The derivative of x to the negative 1 is, put the negative 1 in front, subtract 1 from the exponent, which is going to be that, right? Okay? And then I'm going to take this thing right here and rewrite it with the derivative in there instead and with the y in there instead, and then everything will cancel and we're going to be happy. Okay? So x times y prime becomes x times 1 plus x to the negative 2.
X plus.
Plus x to the negative 1.
And then plus y, which is x minus x to the negative 1. And that's equal to x.
2x equals 2x.
Got it? Yeah, because if you distribute the x times 1 is x. X times x to the negative 2 is x to the negative 1. Plus x minus x to the negative 1. 2x. Cancel, cancel. 2x equals 2x.
So basically, once you plug them all in, we can just say the answer equals the answer.
Well, no, I mean, you're supposed to show the work that gets that. but-
That's shit right there.
Yeah.
I'm gonna say right here.
1 equals
Basically,
1. So-
I know, Chad stays on like one line for every problem he does. Chad's cheat. See, how do you just take up 2 points? You know, oh, crap.
Yeah.
Are you serious? Yeah. Get it done.
You guys got
you
work.
gotta do it.
You got nothing.
Why do I?
You said you're gonna do it.
Now I remember you thinking it was time, and you sat there yelling at me.
You're right. I'm actually the only one who got us anywhere.
I know, actually, you did. I went all over that.
Okay, this is going to be a little bit gross.
Yeah.
Just brightened my day already.
Yep, this is going to be a little ugly. We're doing something called slope fields or direction fields.
Euler's method.
We're not going to do Euler's method, we're just going to do the direction fields part.
Yeah, you best be tailgate.
You
guys try?
So
If it doesn't rain.
It's just like magnets and stuff. Throw these up. Why have to grow in?
Nope. Good guess though.
Fly up for chunks coming.
Fly.
Okay, you ready? I will apply it for you. I'm going to do 3 examples. And the third example is an application. Okay, so direction fields, which are also called slope fields. Okay? It says, unfortunately, it's impossible to solve most differential equations in the sense of obtaining an explicit formula for the solution.
How sad.
Yeah, how sad. In this section, we show that despite the absence of an explicit solution, we can still learn a lot about the solution through a graphical approach, which is direction fields, or a numerical approach, which is Euler's method, which is not a AP topic. We're not going to worry about that. So we're going to start with y prime equals x plus y. And we also know that the point 0, 1 is on the graph. Okay? So if we wanted to come up with a solution to this like a month ago or whenever we were doing these, you would take the antiderivative, right? And then you have that plus c thing on the end, right? And then you plug in 0 for x and 1 for y and solve for c, and that would be your answer. Do you kind of remember that? Okay? The problem is we got a y in here, and we can't take the antiderivative of an x and a y. Okay? So basically what we're going to do is we're going to come up with an estimate for the graph. We don't know a formula for the solution, so how can we possibly sketch its graph? Let's think about what the differential equation means. The equation y prime equals x plus y tells us that the slope at any point x plus y on the graph is equal to the sum of the x and the y coordinates. Right? That's what this is saying. The slope of my graph at any point is going to be the x coordinate plus the y coordinate. Okay? All right? In particular, because the curve passes through the point 0, 1, its slope there must be 0 plus 1 equals 1. So a small portion of the curve near the point 0, 1 looks like a short line segment through 0, 1 with a slope of 1. Catch that? Don't lie to make friends, Jensen. All right, let me see if I can find a... dots. Do those look like dots? Am I missing something? Oh, those kind of dots. What's that? Dim lights? All right.
Yeah, where's Lynette?
I don't know where Olivia is.
She didn't go with the text yesterday.
She's in Arizona. She'll be here tomorrow. All right. So what? Yeah, I am recording for Linnea. I assume she's the one that watched it yesterday, Ben, not you.
What?
I assume that Linnea is the one who watched the video from yesterday, not you. We had one view. I checked this morning when Ben came in because I was going to yell at him, but then it said one view, so I didn't know if it was him or not. But pretty sure it wasn't. All right. So we know that our graph goes through the point 0, 1, right? Because it says that. Gave us that initial little thingy. So what's the slope of the graph at that point? 1. So what I'm going to do is at the point 0, 1 is I'm going to make a little line with a slope of 1. So we know that the graph is going to kind of look like that as it comes through that point. We don't know what it does. Are you going to fall asleep again? What? Are you going to fall asleep again?
No, I'm good. I'm good. I got sleep.
Oh, all right.
fell asleep.
It's kind of awesome to watch yesterday because it was just, you were struggling. It was great. Okay, so now we don't know what happens after that point, right? But we can figure out the slope of the graph anywhere else by doing the slope equals the x plus the y. So it seems like this point, or the graph kind of goes this way. So what is the slope at this point right here? 3, because the coordinates of the point are x equals 1 and y equals 2. So now the graph right there would be super steep like that, right? Okay, so what point does it go to after it passes through there, do you think? Maybe it would go 2 up from there, right? Because it has a slope of 3, so I don't know, up 1, or up 1, 2, 3 over 1. So this point right here would be 2, comma, 1, 2, 3, 4, 5. So that's a slope of 7, right? So now it's going to be really, really tall, okay? So it doesn't really matter, but what you can see is what's happening to the graph as it goes this direction. What's happening with the slope? It's get what? Did you say decreasing? Increasing, yeah. The slope is increasing. It's getting steeper and steeper and steeper. Okay, so the graph is going to look something like that, right? What? Yeah, we're kind of estimating a little bit. We can't figure out the exact thing. All right, now let's talk about what's happening over here on the other side. So as it goes to this way, what's the coordinates of this point right here? 0, well, -1, 0, but yeah. So if you add those together, you get a slope of what? -1. So now we need to make a little -1 type slope of thing going this way. Okay? And then if it goes over here, maybe ends up at this point right there, what's that slope?
-2.
-2, comma 1, right? So then that would also have a slope of about -1. -2 plus 1 is -1. Huh?
Yeah, it was 3.
What looks like
But
3?
you're over 3.
Oh, you want this like right here?
Yeah, you went over.
Oh, okay, so you want this sort of more like, all right, that's how you like that? You happy now?
Look at your point.
Yeah, I hear you.
Yeah.
Okay, my bad teacher card. All right, what about this one right here?
That's good movie.
There it is.
Bad teacher?
Yeah.
0.
It's the only argument I need. What?
You're negative.
What is this? Negative 3 comma 2. So negative 3 plus 2 is going to be negative 1 again, right? And so what's going to happen here like this? Same thing, okay? So the graph on this side is going to turn around at some point and then kind of pooch off that direction and look like that, okay? And so what we just came up with using the, does it look legit? Okay, is sort of a rough sketch of the graph using the slopes of it at different points. Okay, now if you want to turn to page 608 and look on the bottom of page 608,
There.
they made an entire what's called slope field or direction field. See all those little blue segments? That would be the slope of the graph at any particular point on the whole thing. So they went through and they made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 by 11. So they've calculated like 121 different slopes. Made all the little line segments. So that's what all those line segments come up with. Those are just the X and the Y coordinates added together. And then that gives you the entire slope field, okay? And then the advantage of that is that if you're given a different initial point, then you can see what the curve is going to do, you know, anywhere on the graph. You can start at a different point and sort of trace your way through by following where the little lines point you. Okay? That make sense? Yeah, that's what we're going to do next in example 1. Okay, we are going to sketch the direction field for the differential equation y prime equals x squared plus y squared minus 1. Okay? You ready? Okay, so the way you make a slope field is you start by making a xy table. But it's a bad xy table because you know from like when you were in algebra that the x's that you want to use are -2, -1, 0, 1, and 2, right? But you need to do those same x's for a whole bunch of different y's. So the first thing we're going to do is figure out what the slope is of all of those 1, 2, 3, 4, 5 points using this equation right here for our slope. Okay? And then we are going to supposedly go around again, figuring out what the slope is, negative x equals -2, -1, 0, 1, 2, but this time when y is equal to 1. Okay? And then we should do that again for like y equals -1 and, you know, blah, 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 blah.
Why do we need to find the y prime?
Because that tells, y prime tells us the little line segments, what they're going to look like, which is what makes up our slope field.
So that's what's
The y prime thing tells you what the little segments are that allows you to kind of sketch the graph.
That's that equation.
Okay. All right, so let's figure out what the slope is at those different points. How many are you? 1, 2, 3, 4, 5, 6, 7, 8, 9. Justine doesn't count. Okay, so Lacey, you do those two. Georgiana, you do those. Matt, you got an easy one. You need the calculator, do those. Tyson, give us those. Nate, do 2 and 0. You're just going to plug those into here, right? Zach, -2 and 1. Chad, -1 and 1. Ben, 0 and 1. Casey, 1 and 1. You got an easy one also. And I'll do 2 and 1. So yours, 0, 0, you give you 1.
4.
Oh, good. -1. 4 for which one?
-2, 1.
-2, 1. Yeah, you must be mumbling today. -2, 1, you get 4.
Next one.
Yours is, well, which one was that? 1, 1?
Add 1, -1.
Yours is this one? Okay, Ling Sing, what'd you say you got? 3.
Mine's also 3.
And you must be this one?
Yeah.
Okay. Ben? 0.
No,
You-
yeah, that one's 0.
Oh, but they're both 0?
I'm 0-1. I'm only,
Oh, you're this one right here?
this 0.
Okay. So did I do that right? Because that one's going to be 0, that one's going to be 0, and then just waiting on me, that's going to be 4. Okay, so that tells us the slopes of the graph, all of the potential graphs at these different points. Okay? So you ready? Somebody copy them down so I don't have to flip back and forth the different pages. Okay, so let's see. What point is, what was the first? Okay, so what's the coordinates of the first point? Negative 2, 0. So right here at negative 2, 0, the slope is, hey, at negative 2, 0, the slope is 3. So that means I have to put a segment with the slope of about 3. And I'm just making that up, just estimating. Okay, so then at negative 1, 0, the slope was 0.
Yeah.
Okay, so that's an easy one. So that's going to be a flat line right there, which you can't see. And then at 0, 0, the slope is negative 1. Okay, and at 1, 0, the slope was 0 again. All right, and what else? 3. The slope was 3 over here. Okay, so does that make sense where those little segments are coming from? Kind of? Yeah, right. Okay, and then how about, what did we do, y, what was the other, y? Negative 1, or, oh no, we went with y equals 1.
1.
So now up here, what is the slope at negative 2, 1? 4. Okay, so that's going to be steeper than this other one. What else do we have going there? Negative 1, 1, the slope was what? 1? How come they got? Oh, no, we're good. Sorry, negative 1, 1, the slope was what? 1. Okay, so that's going to be a thing like this. And then what's the next one?
0, 1 is 0.
Okay, so this is going to be flat again.
And then 1, 1, 1.
And then that's 1.
2, 1, 4.
4. Okay. All right, so if you, again, look at page 609, they have filled the entire page with, you know, all those little line
They're
segments.
using like,
Okay.
like
What's that?
1.5.
Yeah, that's why ours don't really match up, huh? They went pretty hardcore there because they're yeah. So they got into more detail, and you can see why. Because if you look at this stuff that we have going on here, yeah, it doesn't even make sense. How could you go from here and then be flat or something like that? So you have to kind of zoom in a little bit and get more detail. Okay. So yeah, obviously they did this with. A calculator or a computer or something like that, right? A calculator. But you guys get the idea, right? You guys have your practice books with you?
Yes.
Will you turn to page 5 in your practice book?
No, like, it's not like you hold it. You just like said something. You made a comment.
Page 5.
What are we doing?
Okay, number 14,
Well, it has to do with it written on.
girls.
Oh, sorry.
They're gossiping hard.
I know. If you look at the bottom of page 14, then they have an example of a slope field question that you might face
Look, I got.
on the
What question?
AP calculus test, number 14. Okay?
Multiple choice, I'll dig that.
So what they've done here on number 14 is they have given you a slope field to look at. Okay? And then number 14 on page 5.
Oh.
And then you are supposed to figure out which one of those equations would fit into that slope field. And Matthew, you said B because why?
Because it's not, it starts at 0.
Right.
Because somebody wrote in this book, and the graph starts at 0, like the sign.
Okay. Yeah, so if you look at the sort of just the sense of what the graph would be by looking at that, it starts at 0, 0, it goes up, and then it goes back down, and then it comes back up, right? So that looks like it might match up with a sine graph. Okay, so that's the basic idea.
So you get one out of that?
What's that?
So you get one.
So you get 1 point, 1 what?
What did you say the answer was?
How is
B,
it?
sine.
How's that?
Not like one. Oh, page
Uh-huh.
five, not number five. Like,
Point x equals 1.
At the point x equals 1, okay?
Positive, slope the whole way.
Yeah,
Like I say,
yep. Okay? Alright, so I know that's kind of wacky, but I don't know what to tell you. So I'm not going to make you do a slope field one because it takes a long time, but these are matching problems. So they're going to, just like on the one in the practice test there, they're going to give you 4 different slope fields, and you need to match the differential equation with the slope field. Maybe we'll make the slope field when we're doing a practice AP test, but not
It was in math.
right now.
Yeah.